Okay, this is the third video segment for solution of assignment number 10. And I'm going to do these problems in the box at the bottom left corner. In the book, when you look at problem 27 through 32, there are two different approaches that are proposed, and they're more or less the same, but the way you look at them are different for getting to the final answer. So let's start with number 27. Number 27. Okay, so what have we got here? Sine of cosine inverse of 3 over 5, and it says you find the exact value. Okay, so solution 1, the way it's proposed in the book, is like this. Call this thing u. We want to find sine of u. Want to find sine of u, where u we call to be cos inverse of 3 over 5. Now remember, as soon as you do this, it means u is between pi and 0. As soon as you say u equal to cos inverse something, that u is between 0 and pi. And cosine of u is equal to 3 over 5, of course. That's the meaning of this. So what they do is they draw a triangle, right triangle, with an acute angle u. Okay, the fact that cosine of u is 3 over 5, this means that the adjacent is 3, the hypotenuse is 5, and therefore, based on Pythagorean's theorem, Pythagorean's theorem, this is 4. Therefore, the thing that we want, sine of u is equal, just look at this diagram, sine of u is equal to opposite, which is 4, over hypotenuse, which is 5. This is solution 1. Now, how does solution 2 work? Solution 2. The first step is the same. In other words, we want sine of cos inverse of 3 over 5. We want to find this, right? And we're going to call this thing u, exactly like before. So right away, we know that cosine of u is 3 over 5. And u is between pi and 0. Then we want sine of u, but sine of u, we know what it is. It's plus or minus square root of 1 minus cos squared u, which means plus or minus square root of 1 minus 3 over 5 squared, which means plus or minus square root of 16 over 25, which means plus or minus 4 over 5. Now, which one? The question is it plus or is it minus? Well, because u is between 0 and pi, sine is always positive, because u between 0 and pi means that you are in this quadrant, in these two quadrants, okay? And sine is positive. So the correct answer to the final to this problem is sine of u is equal to 4 over 5, which means sine of cos inverse of 3 over 5 is 4 over 5. Two ways. Okay, let's go to the next page, next problem. I don't know why it goes on the top. Okay, so let me get to this junk. Okay, 28. Tan of sine inverse of 4 over 5. Okay, solution 1. We call this thing u. As soon as we do that, means sine of u is equal to 4 over 5, and u is between pi over 2 and minus pi over 2. Okay, so we're going to draw a right triangle with an angle u here. Okay, the fact that sine of u is 4 over 5 means hypotenuse is 5, opposite is 4, and obviously Pythagorean's theorem will tell you adjacent is Pythagorean's theorem, path theorem. And what we want is tangent of u, and tangent of u is just opposite, which is 4, over adjacent, which is 3. Okay. Now, uh, this is this is fine. Okay. Let's do solution number two. Solution number two. I do want to make a comment here, by the way, and that is before I go any further, tangent of u is equal to sine of u over cosine of u. Okay, this was positive, was given to us as 4 over 5. The very fact that u is between pi over 2 and minus pi over 2 tells you that cosine is also positive. Okay, therefore this whole thing, whatever you write here, should be a positive number, and it was. And this issue is going to play a role in the second approach. So let's see now. Second approach, we start with exactly what we had. In other words, tan of sine inverse of 4 over 5. Okay, and we call this thing u, just like before. So as soon as we do that, sine of u becomes 4 over 5, and u 4 over 5, and u is between pi over 2 and minus pi over 2. Okay, fine. Now, tan of u is equal to sine of u, no problem, we got that, over cosine of u. So sine of u over plus or minus square root of 1 minus sine squared u. Okay, this is where you have to be careful because, well, the sine of u is not an issue. It's up there. The denominator is plus or minus, but remember I said that if you are here between pi over 2 and minus pi over 2, cosine must be positive. 1 minus sine squared u. So this is going to be 4 over 5 divided by square root of 1 minus 4 over 5 squared. And believe me, this is going to be 4 over 5 divided by 3 over 5. And this is 4 over 3. Remember, if you go the second root, you have to decide on the correct sign, algebraic sign, and that has to be relied on by saying that the value of u is between pi over 2 and minus pi over 2, 90 degrees and minus 90 degrees. Therefore, their cosine must be positive. Please, if you don't understand what I'm trying to say, slow it down, draw the trig circle, and you'll find out when the angle u is between 90 degrees and minus 90 degrees, cosine is positive. Okay? All right, let's go to the next one, which is 29. Okay, so let me, one day I'll find out how to insert pages here without, let me insert a blank page here right now. At least we can do it right there. Okay, we have a few pages. Okay, let's go up there. Number 29. We're going to do it both ways, solution 1 and solution 2. 29. We have secant of sine inverse of 12 over 13. Okay, let's call this thing u. As soon as we do that, sine of u becomes 12 over 13, and u is between 90 and minus 90 degrees. Fine. Now, then we're going to draw a triangle, right triangle here. There is the angle u. The hypotenuse is 13. The adjacent, the opposite is 12. Based on Pythagorean theorem, square root of 13 squared minus 12 squared. I think this is good. This is going to be 5. Yeah, this edge is going to be 5. Okay, so we want secant of u. And secant of u is 1 over cosine of u. And cosine of u, you look at this diagram, cosine of u is 5 over 13. adjacent over hypotenuse, and this is 13 over 5. Okay, approach 2, solution 2, we start with the same thing, secant of sine inverse of 12 over 13, call this thing u, so we have sine of u equal to 12 over 13, and u is between pi over 2 and minus pi over 2. U is between pi over 2 and minus pi over 2. Okay, what do we want? Secant of u. Secant of u is 1 over cosine of u, and cosine of u is 1 over plus or minus square root of 1 minus sine squared u. The question is, do I pick positive or do I pick negative? Now notice that because u is between 90 and minus 90, cosine is positive, the whole thing must be positive, and therefore this must be 1 over plus, don't take the minus, 1 over sine squared u. And just plug in your values there, you're going to get 5 over 13. Same, sorry, not 5 over 13, 13 over 5. Okay? And what that means, of course, is secant of sine inverse of 12 over 13 is 13 over 5. Okay? All right, that takes care of 29. Let's go and do number, which one is the next one? 30. 30, okay. Let's do it here. 30. We want cosecant of cos inverse of 7 over 25. Solution 1, let's call this thing u. So immediately we have cosine of u equal to 7 over 25. Okay, 7 over 25. Good. And we know that u is between pi and 0 because we're saying u is cos inverse. So as soon as you say that, you have u between 0 and pi. Okay, so we're going to draw our triangle. Let's put the stuff here. If cosine of u is 7 over 25, this is the angle u, the adjacent is 7, hypotenuse is 25, and by Pythagorean's theorem, I don't know what this thing is, square root of this other edge is 25 squared minus 7 squared, and this is 625. I hope we get a right nice round number, 49. I don't know, I have to use my calculator here, so let's try it. Calculator, square root of 625 minus 49. Yes, 24. This is good. 24. So this is 24. So we want the cosecant of u, which is 1 over sine of u, which is 1 over, well, sine of u is the opposite, 24 over hypotenuse, 25, and this is 25 over 24. We don't have to worry about, any algebraic signs because, look, if u is between 0 and pi, sine of u is positive. Whatever we write here must be a positive number. So this is solution 2. This is solution 1. Now what's solution 2? Let's write it again. So we want secant, cosecant of cos inverse of 7 over 25. We want to know what this thing is. So we call this thing u. As soon as you do that, cosine of u becomes 7 over, oh boy, when I get to this stage, it always jumps up. Cosine of u is equal to 7 over 25. and u is between pi and 0. We know that, okay? And we want to find cosecant of u, which is 1 over sine of u, which is 1 over plus or minus square root of 1 minus cosine squared of u. But we know that u is between 0 and pi, so this whole thing must be a positive value. Sine must be a positive value. So just pick the positive. 1 over root of 1 minus cosine squared u, because sine of u is positive, right? All right, just plug it in, and you're going to get 1 over square root of 1 minus 7 over 25 quantity squared, and this is going to be 5 over 4, right? I think it was 5 over 24, not 4, 24. That's exactly what we got. Not 5, 25. 25 over 24. 25 over 24. That's exactly what we got up here. Okay, let's do the next one. This is 31. Did I do 31? No, 31. 31, we have tan of sine inverse of 12 over 13. Solution 1, call this thing u. So immediately we have sine of u equal to 12 over 13. And u is between pi over 2 and minus pi over 2. Draw your triangle, right triangle. This is u. Hypotenuse 13, opposite is 12, and we know that this one is going to be 5. Yep, Pythagorean theorem. Square root of 13 squared minus 12 squared is 5. Good. So what do we want? We want tangent of u from this diagram. Tangent of u is going to be, incidentally, sine of u over cosine of u. Yes. But it's going to be opposite over adjacent, so equal to 12 over 5. Now, we better make sure that there's nothing wrong with the algebraic sign here. Notice that if u is in this range, 90 and minus 90, sine is positive, of course, because it was given to us, and cosine is also positive in that range. Cosine is positive, so that's the correct sign, correct algebraic sign. Solution 2, let's write again, tan of sine inverse of 12 over 13. Once again, immediately we call this thing u, so we have sine of u equal to 12 over 13. And u is between pi over 2 and minus pi over 2. These steps are the same. Okay, good. Now, okay, so what do we want here? We want tangent of u, which is sine of u, over cosine of u, which is sine of u, over plus or minus square root of 1 minus sine squared u. And once again, the algebraic sign must be consistent with where u is. Now, u is between pi over 2 and minus pi over 2, so obviously this is positive, and this is positive, okay? So this whole thing is going to be a sine of u over plus square root of 1 minus sine squared u. This is because in that range, when I say range is pi over 2 and minus pi over 2, both sine and cosine are positive. Now, if we plug in the values that were given to us, for example, 12 over 13 divided by square root of 1 minus 12 over 13 squared, we're going to get exactly the same answer that we got earlier, namely 12 over 5. I'll let you finish this, 12 over 5. Okay, the last problem from this group, number 32. 32, We want cotangent, I can see this, cotangent of sine inverse of 2 over 3. Solution 1, call this thing u. So we have sine of u equal to 2/3, and u is between pi over 2 and minus pi over 2. Draw a triangle. There is your u. Hypotenuse is 3, opposite is 2, and this one is going to be square root of 5. Good, and just leave it like this. Don't use decimals, don't use your calculator. Okay, so what do we want here? Cotangent of u equal to cosine of u over sine of u, or adjacent over opposite, which means root of 5 over 2. Now, as far as the algebraic sign, it's always a good idea to check, because in this range, sine is positive, okay, and cosine is positive, and the whole thing must be a positive number, and it is. So solution 2, start cot of sine inverse of 2/3. Call this thing u. So we have sine of u equal to 2/3, and u is between pi over 2 and minus pi over 2. Okay, so we have cotangent of u equal to cosine of u over sine of u. This is plus or minus square root of 1 minus sine squared. Sine squared u divided by sine of u. Now, in this range, both cosine and sine are positive, so this fraction must be positive, and you're going to take the plus sign, square root of 1 minus sine squared u over sine of u. And plug in your values. This is 2/3, yeah, and this is square root of 1 minus 2/3 squared. And the top is root of 5 over 3 divided by 2/3, and this is root of 5 over 2, and I hope this is what we got before. Yeah, root of 5 over 2. So I'm going to stop this segment. The last segment is going to be done in a few minutes.